Welcome. Today we will discuss about an important technique and tool which is being used very regularly in data science to control the big data, that is principal component analysis, or in short form PCA. If you have big data, you have lot of features, lot of columns in your hand, but at the same time it is very much difficult to visualize those information due to the high value of dimensionality. At the same time, with a large volume of data, it is very troublesome for the system to run all the algorithms, all the mathematical calculation in behind. So sometimes we reduce the dimension of the data set, but how it has been done? Basically, we are not deleting any features. We are getting the linear combinations of all features, and those linear combinations are called principal component. Now, you might have 80 columns, but there are 10 principal components which can capture the variance to a substantial percentage of data variance. And instead of using the whole data set, we can use those principal components. Let us see the theoretical background of that. So this is the overview of principal component analysis. It is the simplest and most fundamental statistical technique used to reduce the data dimensionality. When it is required, we have already mentioned, to bring it to the lower dimension and curb the unnecessary or low impacting variation effects, we apply this technique called principal component analysis. In this method, we choose the most important features from the given set of data set by way of their linear combinations and remain with lesser dimensions or lesser features to work with. Please remember that we are not deleting any features. We are making linear combination of those features and use that combination as one dimension. Now, what are the prerequisites of performing PCA on the dataset? The dataset should be manipulated. First, we should segregate the dataset into numerical and categorical variables and apply PCA on the numerical variables only. Erroneous and missing values to be imputed before applying this technique. Outlier treatment also arise as per the business needs. It cannot be applied on sparse data. What is sparse data? Which data set having many zero values. So the variable with higher percentage of zero value should not be counted. The target variable, if any, should be kept aside before performing PCA because it is an unsupervised learning. Now, what are the advantages of principal component analysis? It removes the correlated features. If the independent features have multicollinearity, then they have their own effect on each other. Principal components removes correlated features. It is considering only the independent features. It improves visualization. As the dimension is reduced, it can be visualized properly and easily. We can get the insights from the visuals. It improves the algorithm performance because substantially the volume of the data is reduced. Hence, the algorithm give fast performances. It reduces overfitting and reduction of noise. What is noise? That is the variation inside the data set. So it captures the maximum variation and the small variations In the process, it is ignored automatically. On the contrary, what are the disadvantages of principal component analysis? Independent variables become less interpretable because for model building, we are not using those features alone. We are using their linear combinations. So it cannot be interpreted individually those features. It is interpretable in terms of their linear combinations. Data standardization and outlier treatment is must before PCA. Because otherwise big value data will always give more weightage, more bias to those features. All categorical features are required to be converted into numerical features by encoding methods before PCA can be applied. Because PCA is a linear combination, it requires numerical values. That is why we have already told as a prerequisite, either we can segregate those variables and apply PCA on the numerical values only. Or otherwise, categorical values can be coded into numerical variables and then apply PCA on the combined data set. Another thing is information loss. That has to be considered. If the information loss is less, then we will go forward with the principal components. But before applying PCA, we should remember some points. PCA effectiveness depends upon the scales of the attributes. If attributes have different scales, PCA will pick variable with highest variance rather than picking up attributes based on their correlation. That we have already mentioned. Changing scale of variation can change the PCA. Interpreting PCA can become challenging due to presence of discrete data. Presence of skew in the data in long thick tail can impact the effectiveness of the PCA. So basically in PCA assumptions, it is assumed that all the variables are normally distributed and with same variance. PCA assumes a linear relationship between attributes. It establishes those relationships. It is ineffective when relationship. So these are the overview and the theoretical viewpoint of principal component analysis. In our forthcoming videos, we will see how the algorithm is applied to get those principal components and how those linear combinations can be easier to handle for future prediction or future process or model building, you can say. Thank you.